Chapter 3.4 exercises 23 through 36. This is the section of the book that has to do with properties of logarithmic functions. And we're going to look at the odd number problems in this set. In exercise 23 through 28, use the change of base formula and your calculator to evaluate the logarithm. So we're going to be resorting to our calculator, and we're going to talk about briefly the change of base formula. And that formula is, the law actually is for positive real numbers A, B, and X with A not equal to 1 and B not equal to 1, log, this is the formula, log base B of X equals log base A of X over log base A of B. And the very purpose of this I'll just label this change of base formula. The main purpose of this formula is that if you look at a keypad here for a TI-84 plus Silver Edition calculator, these calculators will have maybe a log key, which is a common logarithm, and an ln key, which is a natural logarithm. So the ln is going to be essentially log base e, and the common logarithm, which is log, is going to be log base 10. And so, like problem 23, you wouldn't have in most calculators the ability to actually directly enter this expression, log base 2 of 7, to get an answer. So hence we have the change of base formula to allow us to use these log keys and ln keys in the calculator. Common logarithm for log, natural logarithm for ln. And so here we are at the problem. We're going to go ahead and rewrite this and evaluate. What I'm going to do is rewrite this using the change of base formula. So it'll be log base B of X. What we're going to do is we're going to take log, when I say log this time without a subscript, I'm talking about log base 10 of 7 over log, and just with log, that's log base 10 of 2. And so we can go to our calculator, and for me, I happen to have this TI Inspire CX calculator that actually can get the real, evaluate the actual log. So I'm going to go to press Control Division, and I'm going to put log okay, and here they allow us to put the base, so I'm going to put log base 10 of 7 over log base 10 of 2. And for that we get the value 2.80735. So that'd be off to 5 decimal places. using our calculator. Now, next odd number problem, which is 25. This one here, I'm going to, instead of changing to the log base 10, I'm going to use the change of base formula to use the natural logarithm, because we can use any base we want. So this log base 10 at 175 is going to be equal to the natural logarithm of 175 over the natural logarithm, which is log base e, of 8. So let's go ahead and do our calculator. Okay, we just have ln, which is natural logarithm of 175, over the natural logarithm of 8. And for that, we get the value of 2.48374. Okay, so it's going to be, now these are irrational numbers that go on to decimal places to infinity, toward infinity, but we're just going to realize that and box this in nevertheless as our correct answer. Next odd number problem, which is 27. I'm going to rewrite this log base 0.5 of 12. So it's asking, what power do we have to raise 0.5 to equal 12? Well, since this 0.5 is less than 1, we should get a negative for an answer, but we just use our change of base formula. We're going to use the natural logarithm again, which is the natural logarithm of 12 divided by the natural logarithm of 0.5. Okay, so go to our calculator again. Natural logarithm of 12 divided by natural logarithm of 1/2 or 0.5. We get negative 3.58496. So that will be our answer to problem number 27. Next set of problems. In exercises 29 through 32, write the expression using only natural logarithms. Well, again, this is a change of base formula application. In this case, we're not asked to use our calculator, just rewrite the expression. So we're going to use natural logarithms, which is going to be the ln, or log base e. So ln equals log base e. And so we're going to rewrite this as ln of x divided by natural logarithm of 3. So that'll be it. I don't think there's anything further to do on this one. Okay, next we have problem 31, log base 2 of the quantity a plus b. And for that, these are same. That's going to be equal to the natural logarithm of this quantity a plus b over the natural logarithm of 2. That's it. Nothing else to be done here. Next odd number problem, 33. And now we're going to be using, it says for this set, use common logarithms. Well, common logarithms equals log base 10, which we just write as log. The notation log without a subscript means log base 10. So this is going to be equal to log common logarithm, which is log base 10 of x over log common logarithm of 2. That's it. Next odd number problem, we have log base 1/2 of x plus y. So that's going to be equal to the common logarithm of quantity x plus y over the common logarithm of 0.5, or 1/2. I'm going to just write this as 1/2. Okay, now, this is, for me, this would be our answer right here. But the book has gone a little farther on this, and I will go ahead and do what the book does. What happens is this log of 1/2 can be rewritten as log of 2 to the -1 power. Okay? So what we can do with that to the -1 power is we can take this -1, move it out front, and so what that does, that actually makes the whole thing negative. So it's going to be equal to negative the common logarithm of x plus y over log base 2, or log base 10, excuse me, common logarithm of 2. And so that's going to be our answer here, according to the book. But really up here, just the switch up here could be sufficient. Anyway, good luck on the even number problems as a demonstration or learning. Thanks for viewing.